Now, the highlight of what you're going to hear, and I think this is really, really exciting. The Antipodes, why don't you guys come up here? This is a really special team. So if any of you visited their robot here, you notice that it was very different than last year. In the last few years, we've had the FRC robots, which are 120, 150 pounds. FTC is a little bit smaller robot, but you could see anybody who visited there, the science and technology behind what they do is really neat stuff. And one of the things I wanted them to get across to you is that it's not just about the robots. So these girls have, in fact, one of the girls here is from Australia, and she's a robot exchange student. And they have some great stories. They're going to get a better feel for what it's like to design and build the robot, and hear a little bit about what they do outside of FIRST. So let me turn it over. Who's first?
We'll just pass it on.
Yeah.
All right, so I'm Violet.
I'm Emma.
I'm Elizabeth.
I'm Shirsty. Oh, and we're Team Antipodes.
All right, so the organization which runs our competition is called FIRST. FIRST runs 4 different levels of competition: Junior FLL for younger elementary school students, FIRST LEGO League for older elementary school students and middle schoolers, FIRST Tech Challenge, and FIRST Robotics Challenge for high schoolers. We participate in FIRST Tech Challenge.
So the first competition that we participated in was FLL, which is for primary elementary school students, which is a competition which is fully autonomous with one robot on a 4x8 field in which you complete multiple challenges in 2 minutes and 30 seconds.
All right, so here you'll see a video of a run from our FLL year. The robot's picking up loops to bring back to base and score points. We use touch sensors and light sensors and other sensors to navigate around the field, since it all is autonomous, and to avoid dead reckoning.
So our FLL year, we competed in various qualifying tournaments and went to the Northern California Championships and placed second. And we were invited to go to compete in the Open European Championship held in Istanbul, Turkey. We met a lot of teams from all over the world there, and we made a lot of good friends, and it was also just a really big amount of fun. We shaped our other robotics experience after that. It was really fun.
So as a part of the FLL competition, we had to complete a research project based on the theme of that year, which was smart moves. We decided to complete a research project on magnetic levitating trains, or maglevs. In the process of doing that, we built a small-scale version of a working maglev. You can see the final working model right here. And it was quite the process to make this happen. We definitely learned about development and redoing your ideas when you thought they would work and they didn't. We also learned a lot of electrical engineering before we did all the circuitry on our maglev.
So the way a maglev works is you have 2 magnets, and as it passes over the track of magnets, one will turn off while the other is on, which attracts and repels the 2 different sides of a magnet. And so you can see as one was on, the other was off. And then what we did was we realized we didn't have enough power, so we added a 3rd magnet and a 2nd track. And so you can see that they'll phase in and out of power so that there's more repulsion and propulsion going on. This is our maglev working with a wireless remote control. So you just turn it one way and it'll go.
So we presented this maglev, well, a version of the maglev, at Maker Faire, a do-it-yourself festival in San Mateo in 2010. And we also presented it, and along with our FLL experiences, at Google in the form of a Google Tech Talk. We toured around the campus, and it was a lot of fun. got to eat their food. It was great.
We also did some mentoring, so we had another FLL team that we met, and we worked with them and encouraged them to do better, and we're still their mentors, and we have a lot of fun with them.
And during this mentoring session, they're actually on a Skype call to the sister team, which is Robo Squad United in Tasmania, Australia. And I'm actually a member of this team, and I'm here on our robotics exchange. And Antipodes came over to Australia last fall and competed in a competition called RoboCup, in which we competed in the junior dance division. And we created multiple robots. There are 11 robots, and through this, we actually won the World Championships in Istanbul. During this time, we also competed in FLL in the Tasmanian State Championships, which we also won.
So FTC is competed with 4 different scenes on a 12x12 field. You're on 2 alliances of 2, and throughout the tournament you have many matches with, and each time you have different opponents and different alliance partners.
One of the main differences between FLL and FTC are the parts used to build the robot. In FLL, they're all plastic pieces and you can't modify them. While in FTC, you have aluminum pieces which you can customize, and you have other parts that you can use, and the DC motors and servos require a lot more electrical engineering, so it's more complex.
The programming is also different. In FLL, the main program used is NXTG, and in FTC, it's Robot C. NXTG is an image-based programming, while FTC is a text-based programming. And though they are very different, there are still some similarities between them that enabled us to make the switch from NXTG to Robot C. And
as Violet mentioned, you were able to customize parts for FTC because you deal with a lot of big metal things. And so since each team has different ideas for how they want their robot to be, we used a lot of different machines like metal brakes and stuff like that to customize our robot so we could compete with it how we needed it to be.
all right, we also did some CAD modeling. So you can see we've built up our robot on the computer. So this is what we competed with at our first competition, and then between that competition and the next competition, we added on an arm so that we could do everything else. And that's now our robot doesn't fit within the 18-inch size limit cube that you have at the beginning of the match. So in the beginning of the match, we have to fold up, and so we can fit nicely inside it. So this is our starting position.
All right, so at the beginning of the match, you have a 40-second autonomous period where everything is pre-programmed. So each alliance gets 5 preloaded batons, and we put them into our rolling goal right here and push the rolling goal out of the way. Then we go back over the mountain until we get we have an IR sensor on a robot, and there's an IR transmitter underneath the baton dispenser. So our robot lines up with the baton dispenser so it can dispense all the batons. And that is a lot of points for us.
So after the 40-second autonomous period, there's a 2-minute teleop period, and the last 30 seconds of that is called endgame, and during that time we grab the rolling goal and can go up onto the bridge to try to balance with our alliance partner. So you saw we did that, and now we're working with our alliance partner to balance. And that's hard because that means you have to have a lot of communication between you and your alliance partner. And here we're very excited, as you can see, because that was our final match in the Colorado tournament, and we became the Colorado Championships, which qualified us to go to the World Championships in St. Louis.
So the World Championships in St. Louis were held at the large dome where the Rams play, to accommodate the 20,000 students of the 4 different levels who were all competing there. It was a 4-day competition, and we had a lot of fun. In this time, we had our arm, so we can do more things with that. And it came quite in handy in ways we never really imagined. So, play it. Oh, it's working on playing.
Hopefully it's playing. Between the Colorado and the Worlds, we added the arm so that we could pick up batons off of the ground. But that also added a lot of weight to it. And so it was scary because our robot was top heavy and we toppled over during one match. But then we ended up being able to flip ourselves back over using the arm. So it was like we were stuck on our back like a turtle, but we were able to flip ourselves back over. So that was some pros for our adding the arm.
We created a verb called turtling. All right, just skip that. All right. No, well,
No.
you're not technically allowed to do it. And Will.i.am has recently become kind of the spokesperson of FIRST. So while we were at the World Championships, we all got to go to a giant concert with the Black Eyed Peas, which was incredibly fun.
And robotics keeps us all really busy. For instance, this is the 4th presentation we've given in 2 weeks. And FIRST is all about sharing knowledge. And with knowledge, we wanted to share how to use power tools and use them effectively. So that was one of the ways we shared knowledge with FIRST. And FIRST is all about gracious professionalism. So it's about expanding what you know and things like that. So here you can see us all showing how we could use our robot and also explaining different types of power tools to people.
So one of the presentations that we'll be doing is with our local library, and we'll be putting a webcam onto the front of our robot that's connected to a computer in another part of the room, wirelessly connected. And kids will be able to drive around our robot and try to take like surface samples from the ground. And it'll be like they're driving a Mars rover on the planet. And so this is helping to expand kids' knowledge and make more uses of our robot.
So one thing that we do realize about FIRST is that it wouldn't be possible for it to happen without lots of volunteers and mentors. Competitions wouldn't be possible if there were not referees and people manning them, and we know that they play a huge role in FIRST. And if you haven't seen us already, we're at a booth in the lobby. If you have any other questions, want to try driving our robot, or want to check out our maglev, please come see us. All right, thank you.
So if that didn't inspire you to get involved, I don't know what will.